No, the tripod's not dead. No, it's just that I brought it to curling on Thursday.
And then you forgot.
And then I forgot it. It's in the back of my car right now, and I just forgot to bring it.
I'll go get it for you all.
Yeah. Well, see, okay, I don't want to be disrespectful because every time anybody passes away, it's a sad event. And so if you what? Pardon?
At least his music will come out quickly.
Was that a big thing?
That's always the thing when like, an artist dies and they're like not releasing music, they're like labels releases a bunch of their music.
Oh, or their estate, right?
Yeah. But then they like all the albums are like when released.
Yeah, because their estate wants to just make money off of that.
Yeah, because right now this song they released 2 years ago.
Yeah, that's right.
Who's next? Who's next?
So yeah, we can take 20 seconds. You know, we can take a little while to just kind of remember. At lunch we can play one of the songs. At lunch we can play one of the songs. But yes, rest in peace, Juice. You will be missed. I don't know who Juice is, but you will be missed.
Very intelligent.
Good. Well, that's it's always really sad.
You had the best freestyle.
What? Yes, I did. The rest of the Juice? Yeah. Okay. I was in on the weekend. Sorry, Alina. Just listen up. I was in on the weekend trying to print out some stuff for the new unit, but also at the same time I was trying to print out those really bigly, hugely, massively huge review booklets that I promised you. And the printers on the weekend were just not agreeing with me. And so it took me a couple hours to print off this stack of just regular old diploma questions. So what I've decided is in the interim, what that means is in the meantime, yeah, diploma review, massively, bigly, hugely, large review booklets is yeah, whatever. Doesn't matter. Yeah, bigly. Okay, so there's 4 review booklets here. Now, for example, this is the equilibrium review. It goes over a lot of the equilibrium stuff at the beginning.
Whoops, there was a problem.
Yeah, whoops, there was a problem. Whatever, that's fine. Anyways, it doesn't matter. So the 4 review booklets are here. If you want, because you have the opportunity to rewrite a unit exam, of course, I'm trying to make these available to you. I'll try and print them off when I have time. But I just want to let you know the last time I taught this course and the last time I tried to print off of all of these, it took about 5 hours for the printers to do it. Just because I kept having problems, the printers kept jamming, and you just have to supervise them the entire time. So I don't know when I'll be able to get paper copies to you, but you're more than welcome to download these. You have the digital copy, and you can just work it out on paper, and then there's a key attached to the back of every single one of these. So just want to let you know that that's totally there. That's always going to be there from now on. You can print them off at home too. Yeah, if your parents are okay with you printing off 70 pages worth of stuff. Or
if it's for school,
they'll allow anything. Yeah. 3, 4, 5, 6, 7, 8, 9.
Mommy, the picture of Vegas is for school. I don't think it works like that.
It does, you know what? Oh, they like it in my heart.
Oh, yeah.
Dad thinks that all the time. You always imagine that.
Okay. 101. No. Most of the time, the car is silent. Yeah, that's right. That 08 Civic, right? 1.7 liter single overhead cam engine. Holy, all four cylinders.
Yes.
Actually, I made it. And it was like me and
Okay, listen up, please. We are starting our organic chemistry unit. Now, organic chemistry. Organic chemistry it holds a special place in my heart because organic chemistry was my specialty when I was in university. I loved organic chemistry more than anything because I found it so difficult at the beginning. And then the more I worked at it, the more it made sense, and I grew to really appreciate how complex organic chemistry is.
So what you're saying is I shouldn't be excited for this.
Sorry. Yeah, that was maybe the wrong way to phrase this. Organic chemistry is really, honestly, it's fairly straightforward, but you just kind of have to wrap your head around it in the beginning. That's all, and you just have to accept that organic chemistry is going to happen, and then just roll with it, and you'll be fine. Organic substances are substances that are derived from hydrocarbons. Now, what the hell is a hydrocarbon? It's a compound that is entirely made up of just hydrogens and carbons, right? So a hydrocarbon is methane, CH4, or ethane, which is C2H6, or propane, which is C3H8, or butane, or pentane, or hexane, or heptane, or nonane, or octane, or decane, whatever. Okay? Yeah.
Did they literally just take for example, Pentagon and just throw them in front of
Yeah, because what is... Hey, I got a question for you. Shh. Do you guys know what a prefix is? A prefix is a word that you attach to the beginning of another word, right? Pre meaning before. So, do you know what a suffix is? Yeah, it's a word that you attach to the end of another word. And so, organic chemistry has to deal with a lot of, you have to get used to a lot of prefixes and suffixes. For example, I might get a little bit of flack for this, but what does the prefix meth mean? No. Does anybody know? Okay, no. What does the prefix pent mean? 5. What does the prefix hex mean? 6. What does the prefix oct mean? 8. What does the prefix meth mean?
9.
1.
11. 10. 1.
Meth is 1. In organic chemistry, meth means 1.
Why is meth 1?
Methane is C1, but we don't write the 1, it's just 1C, so CH4. Now, in inorganic chemistry, you'll get used to the idea you'll get used to the idea of these prefixes or suffixes meaning something very specific. For example, oh man, I might get in trouble for doing this as well.
Crystal meth.
Does anybody know the proper name for crystal meth?
Methamphetamine.
Methamphetamine. No, I'm not going to show you how to make it. No, I want. No. No. Yeah, structure.
You gotta look at your history and be like,
There we
wait a
go.
second.
It's right here.
Yeah, I know. But I wanna bring up a picture of it. You will. Yeah, I knew I was gonna regret this, but that's fine. You will soon kind of know a little bit about what this diagram means. Now, as of right now, you probably have absolutely no idea what this means. When you look at this, you think, okay, that's a thing, but I don't know what's on that thing. Yeah, okay, so let's see. What elements are involved in this particular chemical? Nitrogen, carbon, hydrogen, right? And sorry, meth means one carbon. And so what this means is this structure has a single methyl group. It's got one methyl group attached to this amine group here. And so this chemical has been altered by adding one methyl group. And that's kind of one of the key components here in methamphetamine. So meth means one. There's a one carbon group attached to this thing. So anyways, I just wanted to bring that up. That hopefully we'll get used to. That's fine. Organic substances contain carbon and often hydrogen, but they don't have to. They may contain other elements as well. And so really typical organic compounds are CH4. That's methane, right? Carbon dioxide is not an organic substance, and we will talk about why that is. I could change CH4 to be Cl2F2. I could swap these hydrogens. I could trade out these hydrogens for some. What do you know? What family Cl and F, chlorine and fluorine, are from? The halogens. So these are halogenated. These are halogenated hydrocarbons or halogenated organic compounds. Glucose is also an organic compound. So the gist of it is that organic compounds are compounds that either are hydrocarbons, they have lots of carbon-hydrogen bonds in them, or they were at one point and we've just traded some hydrogens for something. That's the idea behind this. That's what organic compounds are. Organic substances are not ionic compounds containing carbon-based ions. So let's look through this list of ions, the polyatomic ions. If you want to look on your list, that's totally fine. But we could go through our list of polyatomic ions and we could find things that have carbon in them, and those are examples of something that is not organic. So the first carbonated ion that I see, well, acetate, okay, that is organic, so we're not going to worry about that. Benzoate, that is organic. But hydrogen carbonates are not organic. And the reason why that is, I'll show you the structure of carbonate. So this is a carbonate ion. It's CO3 with two negative charges on it. And so this has nothing to do with carbon, hydrogen something. It's not even close. This is an extremely oxidized carbon, and so we don't consider it to be organic. So sodium carbonate is not organic. Something like potassium cyanide is not organic. What the hell's a charge on a carbide? Do we have carbide on here?
Yeah.
2 minus. There we go. Calcium carbide is not organic. The reason why that is that these carbons are extremely oxidized, and they don't behave the same way that organic compounds do. Organic compounds can be burned, organic compounds can be oxidized. These things can't really be oxidized more than they are already. Carbon dioxide or carbon oxide, monoxide, those are not examples of organic substances. These don't behave like organic substances. So we just say that they're not organic. So what I want you to do is I want you and a friend, you and a partner, to go through the list at the bottom of the page. And I want you to try and figure out, are those things organic or not organic? By the way, the word for not organic is inorganic. That's right.
Beehive, like beehive. Sorry, I'm angry. I'm so frustrated. Like I used to.
You can put an I and an O for inorganic or organic.
But now that I'm here with my mouth, here my book pieces. It's better.
It's better.
My cat's still is starting to smell bad though, so.
Yeah, that's always going to happen.
That's nice.
Yes. Look, is the proper. Fixed. We're gonna get it wrong.
Okay, I'm going to give you 20 seconds to finish up. Pretty easy.
Watch this. Now you're gonna be like all done.
Yeah. I went in C in.
Okay. That should have been enough time to at least peruse these and try and figure out if they're organic or inorganic. Remember, basically what you're trying to do is you're trying to figure out is this containing lots of carbon-hydrogen bonds, or does it contain something that used to contain carbon-hydrogen bonds? Another way of looking at it is anything other than carbonates, cyanides, carbides, and oxides. So the first one, is that it's a carbonate, right? So that's inorganic. The next one, that's organic. The next one, that's inorganic, right? That's the example that we used. CCl4. Organic. It used to be CH4, but then we swapped some of the hydrogens out for chlorines. Okay, what about acetic acid? This is organic. It's got CH bonds, right? So this is organic. Carbon dioxide, inorganic. Potassium cyanide, inorganic. Sucrose, organic. Good. Good. That's the idea. So that's all of 9.1. That's about as much as you need for 9.1. So we've done 9.1 already. Yeah.
I got it right there.
No, there's no Chris. You are going to have, let's tentatively say you're going to have a quiz on Friday.
No.
Yeah.
I say next Tuesday.
No,
next
you're
Tuesday
probably
is
going
an
to have a
amazing
quiz
day.
on Friday. Okay. Organic compounds can be split up into two categories. Something that we call aliphatic or aromatic compounds. These are the two different categories. Either something is aliphatic or it is aromatic. Now, we're not going to deal with this for a while, but aromatic, yeah, the term comes from substances that used to give off a really powerful smell. Now, since it's changed, aromatic compounds are not just smelly compounds, and they don't even have to be smelly compounds anymore. They're substances that have anywhere in their structure this ring in it. So that's a hexagon with a circle.
Whoa.
Or a hexagon with 3 lines in it, but they're all spaced apart from each other. These two things mean the exact same thing. Whenever you see this, you can think this. Whenever you see this, you can think that. Now, you don't know what that thing is yet. You don't know what the hell a benzene ring is. But I'm just trying to tell you, if something has this in it, what is it? If something doesn't have this in it, what is it? It's aliphatic. Okay, that's all you have to know. The simplest types of aliphatic compounds are alkanes. Now, what I want to bring your attention to is the suffix at the end of this name. Anes. Like meth or eth, prop, bute. Okay? So what this means is they only have carbon-carbon single bonds.
Okay.
No.
But it's got an A at the end.
I know. Anes, alkanes, have the following. So they're organic molecules that contain only single bonds, only carbon-carbon single bonds, and they only contain carbon and hydrogen atoms. So they're hydrocarbons with only single bonds. The general formula for alkanes follows the following trend. So it's CnH2n plus 2. What that means is if you had 4 carbons in here, so C4, how many H's would you have? What's 2 times 4? 8 plus 2, 10. C4H10. So that's the formula for butane. What about 1? If you had 1 carbon, C, and then 2 times 1 is 2, plus 2 is 4, CH4. That's methane. What's CH3? CH3, I want to be very clear, CH3 can exist under very, very special circumstances, but only for a very short time. It's super unstable, and therefore we don't think of it as actually existing for a long period of time. Yeah. So methane, CH4, is very stable under most conditions, unless you try and light it on fire. So what that means is if you want to figure out how many hydrogens there should be, you just multiply the number by 2 and then add 2 at the end. That's all. Okay, we want to know some different ways in representing organic structures. And there's 3 different ways I could ask you to represent it, or there's 3 different ways the diploma exam could represent it. Now this really screws people up. The following pictures are going to be the exact same thing, but I want to make sure that you understand the difference between them. A structural diagram must show every single bond and every single atom. So if we were to draw out propane, what is propane? C3, and then 3 times 2 is 6, plus 2 is 8. So C3H8. What we're going to do is we're going to draw propane 3 different times, but in 3 different ways. So how many carbons are in propane?
3.
So 3 carbons in a row. And I don't know if you remember from Chem 20, but how many valence electrons does carbon have? It's got 1, 2, 3, 4. So how many more electrons does it need in order to complete its valence shell? 8. It needs 8 in total, so it needs an extra 4. What that means is carbon can make 4 bonds. So carbon should always have 4 bonds. So how many extra things can bond to this first carbon?
3.
1, 2, 3, and they're all going to be hydrogens. How many things can bond to the middle carbon?
2.
How many things can bond to the last carbon?
3.
3 more, right? Yeah, as long as we understand. Okay, so how many H's are on here? 8. So this is C3H8. This is the structure of propane. Now we can draw this in a different way. We can draw this as a condensed diagram. What that means is we're not going to show every bond, but we are going to show the bonds between the carbon atoms, and then we're going to group the hydrogens and any other substituents that are attached to that carbon. So let's look at this carbon. What things, other than the other carbon, what things are attached to this carbon? There's 3 hydrogens that are attached, right? So what we're going to say is we're going to say CH3, and then we're going to draw a bond. And yeah, what is that CH3 attached to? CH2. And what is that carbon attached to? CH3. Okay, do you see how both of these things are the exact same thing? They're totally identical. It just depends on, 1, how lazy are you? And 2, how well can you visualize the space around the molecule? Let's do our final, and this one's called a line diagram, and this one's hard. This one's very difficult. It'll take a little while for you to get to know kind of how to visualize these. But what I want to bring your attention to, how many carbon-carbon bonds are in this molecule that contains 3 carbons?
2.
There are only 2. Does that make sense? You can't have 3 carbon-carbon bonds if there's 3 carbons, because then that extra carbon would have to be bonded to another carbon. Do you know what I mean?
Yeah.
So it's like the bonds are a bridge between atoms. They're what binds the atoms together, and so for every carbon you need, you'll have 1 less bond. Okay, so how many carbon-carbon bonds are here? 2. And so we're going to draw the line structure. It shows only the bonds between carbons, and any other atoms that are not carbon or hydrogen, you must be able to figure out the number of hydrogens on each carbon. So how many carbon-carbon bonds are here?
2.
Oh, Jesus.
That's
Oh,
That's
Already made it.
Or I could have drawn it like this, or I could have drawn it like this, or like this, or like that, or like that. Do you know what I mean? We're just drawing the bonds. Now let's take a look at this. How many carbons are in this molecule? 3. Can you see where the 3 carbons are? They're at the carbons. There's always a carbon at the end of every line. At the end of every line, there's a carbon. So there's carbon here, there's a carbon here at the vertex, and there's a carbon here at the end of that line. So that's the 3. Now let's think about this. how many hydrogens need to be attached to this carbon here? Well, I only see one bond attached to it, so there must be 3 hydrogens attached to it. Does that make sense? So it takes a lot of looking into what the hell's going on here, but you'll get used to it. Trust me, you will get used to it. What I would like you to do, what I would like us to do, is we're going to go through here, and we're going to draw the pictures of all 10 of the first, hydrocarbons. So what I want you to do is I would like to, and you might have to partner up. You might have to partner up with somebody for some of the really bigger molecules. I'm just going to show you what you're going to do. This is called a molecular model kit. You used these last year when you were doing molecular shapes, right? When you were doing Vesper shapes, Vesper diagrams, stuff like that. I just want to walk you through. The first one is methane. How many carbons are in methane? 1. So the structural diagram, how many carbons? 1. So how many hydrogens have to be attached to this? 1, 2, 3, 4. Right? Carbon always has to have 4 bonds. The condensed diagram, we show the carbons and hydrogens and any substituents just being attached to them. We don't show any of those bonds. So we just show the carbon-hydrogen or the carbon-carbon bonds. Are there any carbon-carbon bonds here? No. So CH4. That's the condensed structural diagram for it. Okay, the line diagram.
I call it.
It doesn't even really exist. We would still say most of the time CH4. Okay, a dot is very hard to represent, so most of the time you'll never see a dot. You'll just see CH4. Let's do ethane. How many are in ethane? How many carbons? 2. 2, and you'll have to get to you will have to know eth means 2. You will totally have to know that. Okay, so we've got 2 carbons. How many hydrogens? 1, 2, 3 on this one, and 1, 2, 3 on that one. So what's the condensed diagram? Basically, anything attached to the carbons, you just suck it into the carbon. So what's on this carbon here? CH3, bond, CH3. And then what's the line diagram? A straight line, right? Because there's a carbon at this end and a carbon at that end. Okay, now what I want you to do, and this is going to be difficult for the really big molecules, but I want you to try and make these molecules. Every time you draw one, I want you to make it. So what you're going to do is the black atoms, those are carbon. Hopefully that makes sense. Black is carbon because it's all sooty and stuff like that. The small white ones, those are Okay, let's try this out. So I'm going to really quickly. The structural and the condensed diagrams, they should be fairly straightforward, but I want to go through the line diagrams just to make sure that we all understand what's going on. You totally don't have to put away your atomic models, your molecular molecules right now, but that's fine. Okay, propane, we've already talked about that. That's basically just that. Perfect, no problem. Butane, that's 4 carbons. Now, the way I draw line diagrams is, remember, just simply putting pen to paper kind of counts as 1 carbon, right? So then every line will be another carbon. So we'll go 1, 2, 3, 4. That's the way I do it. I put my pen down and I say that's 1 carbon, 2, 3, 4. So can you confirm for me that yes, you can see where the 4 carbons come from? Yeah, butane. Okay. Now pentane, remember, 1, 2, 3, 4, 5. That's the way, that's the kind of the rhythm that I draw these with. Hexane, again, would be 1, 2, 3, 4, 5, 6. Heptane would be 1, 2, 3, 4, 5, 6, 7. What? Octane would be 1, 2, 3, 4, 5, 6, 7, 8.
Oh, we
Sure.
get fancy with this one.
Doesn't matter in what direction you make the lines go off on. No, as long as they're about, the lines should be greater, the angle should be greater than 100 degrees or greater than 90 degrees, because you want them to be kind of relatively obtuse. Nane, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure. And then decane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure, whatever. That's totally fine. I'm not going to go through the structural and condensed diagrams. If you want me to, you can stick around at lunch and we can talk about it. That's totally fine. I would like to start talking about, we got 13 minutes to start talking about alkanes. Nope. We're going to start talking about naming alkanes. Okay.
Okay.
So, what you will find out, what you will figure out about organic molecules is that because they're so complex, there's so many different ways of arranging carbon bonds. For example, what I want you to focus on here is that here I've got 6 carbons all in a row, so I've got hexane, but I can make a different compound using 6 carbons. What I could do is I could take the end carbon off and I could put it somewhere else. For example, I could put it in the middle and I could swap out this carbon and this hydrogen.
Then it'll roll it.
And so what I'm curious of, is this still 6 carbons?
Yes.
Yeah.
Yes. I didn't lose any atoms, I didn't gain any atoms. Are you still gonna call this hexane? Do you think it might behave a little bit differently because it's got a different structure now?
Yeah.
Probably. It probably will. Everything's okay. Everything's okay, I think. Everything's fine. Yeah, we're okay. So, we're not going to call this hexane anymore. We're going to call this something pentane. Why are we going to call this something pentane? What's the longest carbon chain you see on here? When I look on the bottom, I see 1, 2, 3, 4, 5. The longest continuous carbon chain that I can find is 5 carbons long. So I'm gonna name the very end of this compound pentane. Now, other than these 5 carbons here, how many extra carbons are on it? 1. I see 1 single carbon. I've got a group of 1 carbon here. Now, what's the word for 1 carbon again? Meth. So I will call this methyl pentane. I will call this methyl pentane. Do you see how the pentane tells you that there's 5 carbons in a row, and the methyl says that there's a methyl group, but we have to be very specific at where it's at. Because I could have a methyl group on the 3rd carbon, or I could have a methyl group on the 2nd carbon. Do you kind of see what I'm talking about?
Yes.
Okay, so let's just talk about what's on our paper here.
I don't like what's on the paper.
The IUPAC rules for naming alkanes are the following. Find the longest parent chain and number the carbons so the branches have the lowest total. So what I want to do is I want to take a look at this. So where do you see the longest parent chain? How many carbons are in the longest parent chain here? Yeah, I could go, don't draw this, don't write this down, but I could do this, and that's 5 carbons. Can you think of any other order that makes it longer than 5 here? No, you can't. You can't draw another continuous section of carbons that's longer than 5. But I want to be very clear. I didn't have to draw that as my parent chain. I could have drawn this as my parent chain. Is that still 5 carbons? So there's no difference between them. It doesn't matter. It looks weird. It's not pleasing to the eye, right? I also could have drawn my parent chain like this. Is that still 5 carbons? Yes, that is. Okay, so, okay, all right, fine, that's fine, whatever. But let's stick with this because I don't want to freak you out too much on the first day of organic chemistry. So that's our parent chain. Let's number them so that the branches on here. Do you see what I mean by branches? I see a 2-carbon branch coming off of this parent chain. Okay? So I could start numbering from the left side, or I could start numbering from the right side. What I mean by that is I could start numbering C1, C2, C3, C4, C5, or the other way. Now, if I started numbering the other way, it would go 1, 2, 3, 4, 5. What do you notice? What branch, what carbon is this branch attached to? C3. And if I number it the other way, it's C3 as well. So it doesn't, in this particular case, it doesn't matter, okay? I want to be very clear. In this particular case, it doesn't matter. So, identify any branches and their location number on the parent chain. So we've got a 2-carbon branch on carbon 3. Write the name of the branches in alphabetical order if there's a bunch of different branches on here. How many branches do we have? 1. We've got 1 branch. Okay, so there is no alphabetical order. It's just that branch. So the way we name this is we name the location, then dash, branch name, and then parent chain. So what's the location of this branch? It's CH3, or it's on the 3rd carbon. So the way I'm going to say this is 3 dash, and then I'm going to name this branch. I should name it according to how many carbons are in this branch. How many carbons are in that branch? 2. So it will be what prefix? It's not methyl, it's ethyl. So ethyl. This is 3 ethyl, and then what's the parent chain? How many carbons are in that parent chain? 5. Pentane. So all one word, 3 ethyl pentane.
All one word.
All one word. There's no spaces in here at all. Okay, let's kind of go backwards and let's see, does this make sense? Let's go backwards. Pentane, so how many carbons in the parent chain? 5, so we should have 5 in the parent chain. And then what kind of branches are on here? Ethyl, so there's 1 ethyl branch, or 1 2-carbon branch on here, and it's at location number 3. So there's a parent chain that's 5 carbons long, and there's a single ethyl branch that's at location number 3. Is that fair?
Yes, sir.
Okay, let's take a look at this other one. Read for yourself step number 1. What is it?
Find the longest parent chain. Number the carbons so the branches have the lowest total number.
Okay, find the longest parent chain, number the branches so that they have the lowest total. So let's think about this. How many carbons are in this parent chain?
So
There are 7, right? So what's the end of this name going to be?
heptane.
Pentane.
We're going to end with heptane. Do you agree that since there's seven carbons in our parent chain? Now, where do you see branches? I'm going to circle my parent chain. How many branches coming off of this parent chain? There's 2. And are they the same type of branch or are they different? They're different. What would be the name of this branch? How many carbons is on this branch? This would be an ethyl. And what would this be? That would be a methyl group. Does that make sense? There's an ethyl and there's an ethyl. Now, okay, let's number our branches or number our carbons. I could either start at the left or start at the right.
Start on the left.
Are you going to start at the left?
Yes.
Okay, 1, 2, 3, 4, 5, 6, 7.
It'd be the same.
So, and it would be the same, not quite the same. Yeah. Okay. So let's go through it. Let's go through it this way. This branch, what location is this branch at?
3.
So this is a 3-ethyl branch. Does that make sense? It's an ethyl group located at number 3. And what about the methyl?
That's 5.
That's a 5-methyl. It doesn't mean there are 5 methyls. It means it's one single methyl group at location number 5. Now, where are you going to put these? Are you going to put these? Are you going to put the ethyl first, or are you going to put the methyl first inside the name? Why?
Alphabetical.
Because you put them in alphabetical order. Okay. So we will go 3-ethyl. Every time there's a number and a letter beside each other, you need to put a dash in between these names. So 3-ethyl, then what goes next? So 5-methyl heptane. Three ethyl 5-methyl heptane. Yes, sir. Oh, I'm so glad you asked that. Okay. We got enough time? Yeah, we got enough time. Okay. Don't write this down. Just listen. Don't pack up anything. Don't do anything. Just listen. So.
Now at the point and stop the head.
You have like 30 seconds.
No, it's not. I can't talk and listen at the same time, so.
Based on
It's
this.
fine. We'll talk about it tomorrow. Shane, can you?
literally just switch.
Yeah, but we have to figure out which one is correct. So only one of these is correct. You can't go 5-ethyl 3-methyl and have both of them be the correct. We need to agree upon one way of doing it. What? No, because if Joe, I'm going to erase this.
Oh no.
But Joe, if I took this and I flipped it like that, then all of a sudden my methyl group is at 3. And if we're going left to right, you know what I mean? You could just flip a molecule. When you're deciding between the two, which one do you think should have the lower number? Why?